Hi. Hi, Assalamualaikum, and a very good morning, everyone. So, today we are going to look at the last subtopic of the chapter, which is chapter 5.4 phase diagram. Okay, so at the end of this lessons, you guys should be able to first define phase, triple point, and critical point, identify triple and critical point on the phase diagram, sketch the phase diagram of water and carbon dioxide, compare the phase diagram of water with carbon dioxide, and explain the anomalous behavior of water. Describe the changes in phase with respect to number 1, temperature at constant pressure, and number 2, pressure at constant temperature. So now let's get started. Okay? Alright. So there are a few keywords that you need to understand in this chapter, which are phase diagram, critical point, triple point, phase change, carbon dioxide, and anomalous behavior of water. So ini memang korang akan banyak kali jumpa dalam this chapter 5.4. Okay. So first we want to know what is actually meant by phase. So phase is actually a state of matter that is uniform throughout in chemical composition and physical state. Okay. So phase is homogeneous. So there are 3 types of phase, which are solid phase, liquid phase, and gas phase. So the water in a glass, water has one phase, which is liquid. When we add some water, it now has 2 phase, which is solid and liquid. Okay, so now what is phase diagram? So phase diagram is shows the region of pressure and temperature at which its various phases are thermodynamically stable. So the regions are solid. So dalam phase diagram, there are region, equilibrium line, and point. So untuk region, the region are solid, liquid, and gas. Okay. And then there are the equilibrium curves or line. So for line C here, this is the solid liquid equilibrium line. Okay, line A here is the liquid gas equilibrium line, and line B is the solid gas equilibrium line. Okay, so the equilibrium curve or line is the line that's separating the region. Okay. Alright. So regions of phase diagram. So each region in the phase diagram, they correspond to one phase. For example, untuk region ni untuk solid je. This region is for liquid and this region is for gas. And a particular phase is stable for any combination of pressure and temperature. Okay. So, phase boundary or equilibrium line or equilibrium curve. Okay. That one is the line that's separating region. And phase change curve. Okay. So it shows the value of temperature and pressure at which 2 phases exist in equilibrium. So for example, the solid liquid equilibrium line, it shows the value of temperature and pressure where the solid and liquid exist in equilibrium. Same goes to this. The liquid and gas are in equilibrium, and this line is the solid and gas in the equilibrium. Okay. So what is triple point? Okay, so this is the triple point here. Okay, this one is a triple point. So what is triple point? Triple point is when solid, liquid, and vapor or gas simultaneously exist in equilibrium. So 3 phase boundaries meet. Okay, kat sini nampak ni solid ada, liquid ada, gas phase pun ada. So kita panggil ni triple point. Okay. So, what is critical point? Okay, this is the critical point. The end point of liquid-gas equilibrium line. So, density of liquid equal to the density of gas. So, maksudnya dekat sini, dekat critical point, the phase boundaries disappears. So, at this point, the average kinetic energy of the molecules is so high that the vapor or gas cannot be condensed into liquid no matter how much pressure is applied. So at this critical point, it is now impossible to liquefy a gas no matter how great the applied pressure is. Okay, and dekat sini juga, the temperature and pressure at this point is where the liquid and gas can no longer be distinguished. Sebab apa? Density of liquid is equal to density of gas. Okay, phase boundaries dah disappear, dah tak ada dah. Okay, macam sama je. Alright, so now, kita nak tengok jenis-jenis of phase diagram. There are two types of phase diagram. There are positive and negative slope. Okay, so positive slope, dia slant to the right. And the negative slope, dia slant to the left. Okay, so kita nak tengok macam mana after this, which type of molecules ataupun component that have this kind of positive slope and negative slope right after this. Okay. So now let's look at the phase diagram of carbon dioxide. So if we look at the phase diagram of carbon dioxide, the solid liquid equilibrium line, the line, it's slanted to the right. So which means that this equilibrium line is the positive slope. Okay. And when we look at here, this slope, this solid liquid equilibrium line, line O ke B ni, is a melting or freezing point. This is the phase where the solid and liquid exist in equilibrium. Okay, for line O to C, this liquid gas equilibrium line is where the liquid and gas exist in equilibrium, which means this is the line where the vaporization and condensation point are at. Okay, so this one, line O to A, is the solid gas equilibrium line. So this is where the sublimation and deposition point are at. Okay, so carbon dioxide at room temperature 25 degrees Celsius and 180 m pressure is at vapor state, vapor phase or gas phase. Okay, memang betul lah kan? Carbon dioxide in room temperature, dia exist as gas. Tak ada pun kita nampak dia exist as solid kan? Betul? Ataupun liquid. Okay. Now, let's explain the phase diagram of carbon dioxide. So, for this line O to A, so this is where the solid and gas exist in equilibrium. Okay. So, this is point O. Point O is what? The triple point. So, at negative 57 degrees Celsius and 5.2 atm, the solid, liquid and gas all exist in equilibrium. Okay. So, here, below the critical point here, okay, at pressure less than 5.2 atm, below the critical point, the phase change from solid to gas or from gas to solid. Okay, so maksudnya when solid is heated at 180 m for example, okay, it will sublimes to gas phase at negative 78 degrees Celsius. Okay, so X here is the sublimation or deposition point. Okay, so when you heat solid carbon dioxide at 180 m, dia tak akan jadi liquid. Dia akan terus sublimes into gas phase at negative 78 degrees Celsius. Okay. So, at pressure above 5.2 atm, so now the phase, the carbon dioxide can change from solid into liquid, then into gas. Or vice versa, from gas to liquid to solid. Okay, so maksudnya, meaning that, the pressure below 5.2 atm, solid memang akan sublime directly from solid into gas carbon dioxide. Okay. However, above 5.2 atm, barulah solid able to change into liquid and change into gas phase. Okay. Alright. So now let's look at, okay, so tadi kita, so just now we just, what we call it, tadi kita tengok yang kalau pressure dia constant, temperature dia berbeza-beza. Okay, sebab apa? At constant pressure, what we call it, dia boleh sorry. Excuse me, okay. I don't know what I'm thinking. Okay, now, let's look at this temperature. So, at temperature negative 57 degrees Celsius, the phase change from carbon dioxide gas to solid carbon dioxide. So, from low pressure to high pressure, the gas carbon dioxide will deposited into solid carbon dioxide. Okay, kalau tadi at pressure 180 m, the solid sublimes into gas or vice versa. Tapi at negative 57 degrees Celsius point, the carbon dioxide gas can deposited into solid and vice versa, from low pressure to high pressure. Okay. Okay, so kalau dekat negative 57. Betul ke negatif? Oh, less than. Okay, Miss tak perasan. Patutlah pelik. At temperature less than negative 57. So, kalau at temperature larger than negative 57, the gas phase will change into liquid first, then change into solid phase. Sama juga, from low pressure to high pressure, dia boleh change, ada phase change from gas to liquid to solid. Okay. So, now here, kita pergi ke line OB. So, line OB is the solid liquid equilibrium line, and it has a positive slope. So, this line OB indicate the melting and freezing point or freezing line. So, since carbon dioxide has a positive slope, okay, the slope slanted to the right, okay, we look here, the higher the melting point, the higher the pressure. Look at here, okay. Nampak? Makin tinggi temperature, melting point dia, makin tinggi pressure dia. So for carbon dioxide at higher pressure, the melting point or freezing point increases. Okay, ni untuk carbon dioxide. This is the typical phase diagram, okay? Okay. So, when we look at this phase diagram of carbon dioxide, dia ada positive slope. Why is that? Because it indicate as at the high pressure, the melting point increases. Because for carbon dioxide, the solid carbon dioxide is more dense or is denser than liquid carbon dioxide. Okay, we know that density is equals to mass over volume. So, density is inversely proportional to the volume. So, the higher the density, the smaller the volume. So, since solid carbon dioxide is denser than liquid carbon dioxide, it occupies less volume than liquid. So, according to Le-Chatelier's principle, as pressure increase, the system will reduce the disturbance by shifting the solid phase by shifting to the solid phase. Maksudnya dia left side occupies smaller volume. So more heat is needed to melt the solid. Okay. So bila more heat is needed to melt the solid, kalau awak tengok dekat phase diagram ni, maksudnya sebabkan more heat is required to melt itu solid, jadi dia lagi favors solid phase compared to liquid phase of carbon dioxide. Okay, faham ke? Disebabkan lagi banyak energi diperlukan to change the phase from solid to liquid. So at high pressure, it favors the formation of solid carbon dioxide compared to liquid because solid carbon dioxide has smaller volume. Okay. So kalau awak tengok kat sini, pushing down the piston decrease the volume of both solid and liquid by a small amount. Kalau awak tengok kat sini. Okay. Bila awak push, liquid lagi kecil daripada solid. So some liquid freeze. So sekarang ni nampak. Dia lagi favor formation of solid. So when pressure increases, some liquid freezes, producing the denser solid. So total volume of solid and liquid decreases. Okay, reminder here that the phase diagram of carbon dioxide is typical of most substance in that solid liquid line. Maksudnya, mostly memang banyak komponen yang akan ada phase diagram positive slope. Okay, which means that the solid of that particular substance is denser than the liquid phase of that particular substance. So that's why the solid liquid equilibrium line slanted to the right and have a positive slope. Okay, however, there will be some component that has a negative slope, which we will be going to cover that after this. Okay, so we have discussed about the equilibrium line and triple point. Now we want to look at the critical point. So at the critical point here, critical point C, above the critical point, the liquid phase cannot exist regardless the pressure. So at line OC, this is the boiling curve, okay? Kalau tadi ni adalah melting and freezing point ataupun curve line, this one is the sublimation line, this one is a boiling punya line lah. Okay, so line OC is a boiling curve where liquid and gas exist in equilibrium. So point C at 31 degrees Celsius and 73 atm, this is where the critical point for carbon dioxide is. It separates this separation of gas and liquid phase is no longer exists because no matter how great the pressure applied onto the gas, it will never be liquefied into the liquid. Okay, using the phase diagram of carbon dioxide, answer the following question. In what phase should carbon dioxide exist at negative 60 degrees Celsius and 6 atm? So if we look here, negative 60 probably should be here. 6 atm probably should be here. So, solid phase. Am I right? Okay, negative 60 degrees Celsius and 2 atm. Negative 60 degrees and 2 atm probably here. Am I right? Gas phase, I think? Yes, true. And then, negative 45 and 10 atm. Negative 45 kat sini, 10 atm probably kat sini. Liquid. So, negative 57 and 5.2, solid, liquid and gas. Betul tak? Yes, betul. Okay, so kalau awak tengok kat sini jawapan dia dah label dah dekat sini point-point dia. Okay, alright. So now, kita nak tengok pula phase diagram of water. Tadi phase diagram of carbon dioxide, normal phase diagram, dia akan solid liquid equilibrium line akan slanted to the right, positive slope. However, for the phase diagram of water, the solid liquid equilibrium line is slanted to the left. It gives a negative slope. Okay, so look at here. H2O at room temperature or normal condition 25 degrees Celsius and 1 atm, it exists as liquid. So yes, water at room temperature dia exists as liquid kan, tak pernah lagi exist as solid kan. Ada kau buka air pipe tiba-tiba keluar ketul-ketul solid? Tak ada kan. Okay, so yes, at room temperature and pressure 1 atm, water exists as solid. So now let's look at the explanation on the phase diagram of water. So we got point O here. This one, point O, is the triple point. So at 0.01 degrees Celsius and 0.006 atm, liquid exists as solid, liquid and gas in equilibrium. Okay. Alright. So at 1 atm here, the phase change from solid to liquid to gas. Okay. Or vice versa. Okay, so they have normal freezing point here at 1 atm 0 degrees Celsius and normal boiling point 100 degree Celsius for water, which is correct. Okay. So, point C here is the critical point. So, the critical point of water is at 374 degrees Celsius and 218 atm. Okay. So, if we look at OB line here, this one is the melting and freezing line point. Okay. Dekat sini lah adanya melting and freezing point. So, if we look tadi, kalau tadi carbon dioxide, dia positive slope. So, positive slope, as pressure increase, the melting point increase. Okay, itu untuk carbon dioxide, normal phase diagram. So, in this case, for water is anomalous case of phase diagram, dia ada negative slope. So, for negative slope, when pressure increase, the melting point decreases. So, maksudnya, it favors the liquid formation of water compared to the solid formation of water. And we will see why after this. Okay, so here, we can see that the higher the pressure, the smaller the melting point. The lower the pressure, the higher the melting point. Nampak kat sini tak? Kan? Betul kan? So, for negative slope, as the pressure increases, the melting point decreases. Okay, Miss ulang sekali lagi untuk positive slope carbon dioxide. As pressure increase, the melting point increases juga. Itu untuk carbon dioxide. Ini untuk water. Okay. So, kenapa kita nak bagi tahu kenapa water ni dia ada negative slope? Okay, sebab liquid, sebab solid water is less dense liquid, less denser than liquid water. So, bila solid lagi less dense, dia lagi ada larger volume. So, bila larger volume, it favors the liquid formation of water rather than the solid formation of water. So, liquid, sebab apa? Liquid H2O has less volume than solid H2O. Ingat, dia akan prefer yang less volume. Okay, sebab tu. So, kalau dia prefer yang less volume, so, sebab apa? According to Lee-Chatterley's principle, as pressure increase, the system will reduce the disturbance by shifting to the liquid phase, smaller volume. Okay. So, the ice will melt at lower temperature and this will explain the anomalous behavior of water. So, bila ice ni melt at lower temperature, so dia lagi prefer exist as liquid rather than solid. Okay? Alright. Okay, kenapa ice melt at lower temperature? Sebab less energy is required to melt the ice. Sebab dia lagi favor formation of liquid. Tadi dia lagi favor formation of solid. Sebab itulah more energy is needed to melt the carbon dioxide kan. So, dia terbalik lah kat situ. Dia terbalik je dengan carbon dioxide tadi. Okay. So, reminder, the phase diagram of H2O is one of few substance in that solid liquid line slopes to the left with increasing pressure. Tak banyak lah kiranya. Water lah yang salah satu yang ada anomalous case. Okay, dia je yang one of the substance yang dia punya solid liquid equilibrium line slope to the left. Okay, dia ada negative slope. Maksudnya dia lagi prefer formation of liquid. Kebiasaannya, normally the solid liquid equilibrium line will slope to the right, positive slope, which means it favors the formation of solid. So, that's it, okay? Alright. So, let's look at the question. In what phase should water exist under a pressure of 250 mm Hg at 85 degrees Celsius? At 85 degrees Celsius, dia akan exist at 85 degree Celsius, steam. Gas lah. 62 degree Celsius, gas juga. Ke? Okay, vapor liquid. Okay. Kat sini. 62 degree Celsius kat sini. So, dia akan exist as gas and liquid. Kalau 30 degree Celsius here, dia akan exist as liquid. So, kat sini kan. And then negative 5, dia akan exist as solid. Okay. Okay, next. Predict what would happen as a result of the following changes. State the phase change. Okay, starting at A, we raise the temperature. So, starting at A, look at here, A. Starting at A, we raise the temperature at constant pressure. So, constant pressure tak bertukar. Dia increase temperature je. Constant pressure, dia akan, starting with A. So, solid will change into, akan go to solid liquid line, go to liquid gas line, go to gas. Third. Yes. Okay. Alright. So next dia kata, starting at C, we lower the temperature at constant pressure. Constant pressure tapi lower temperature. So C, from gas to solid gas equilibrium line to solid. Betul? Yes, true. Okay, then, starting at B, we lower the pressure at constant temperature. So, sekarang temperature sama, kita lower pressure. So, from liquid to liquid gas equilibrium line to gas. Betul? Yes, itu saja phase change. So, harap-harapnya boleh faham. Okay, macam mana kita nak tengok, nak baca phase diagram ni. Okay, that's all for today. So, actually, Miss ada quiz tau. Alamak, Miss lupa nak letak dalam slide. But it's okay. So, quiz kita, saya bagi dekat Google Form. So, here is the QR code. Okay, so you can scan this QR code here and answer the question. You only have 4 questions je. Okay, so kalau siapa-siapa yang dah buat tutorial, dia boleh jawab lah soalan dia sebab sangat senang lah soalan ni. Kenapa tak keluar pula ni? Sabar ya, maksudnya dia nak awak tengok lagi video ni. Okay, right. Okay, ni QR code dia. Boleh scan this QR code and answer the quiz for 5.4 and your attendance will be recorded according to your answer. Okay, that is all for now. So, lepas ni kita akan sambung chapter 6. Okay, bye-bye. Assalamualaikum.